Hello my dear students, I welcome you all for the Samveda e-learning program. You are learning many concepts of light, reflection and refraction from last 4 sessions. Today, you will have some more interesting concepts of this lesson. You will learn how to solve the problems based on mirror and lens. It is very interesting and also these are very important for the point of examination. My dear student, I know you are all curiously waiting for the today's session. Before going to learn about the today's concepts, let us recall what we have learnt in the previous class. My dear student, we have learnt in the previous class about refraction in spherical lenses, ray diagram for the formation of images by lens, sign convention for spherical lenses, and at the end we have learned lens formula and magnification and the formula used to calculate the magnification. My dears, today you are going to learn about the sign convention for reflection by spherical mirrors and lenses again, and you are going to solve the problems. You are going to learn the steps of solving problems based on mirror formula as well as lens formula. At the end of the session, you are going to learn about power of the lens. My dear student, problem solving is very important in case of mathematics and physics. So, we have to follow some rules in solving problems, especially in physics. Now, I will show you what are the steps to be followed to solve the problem. So, we have to read the problems first and we have to draw the diagram. We have to understand the problem first and we have to draw the ray diagram, a simple ray diagram based on the data which is given in the question. And also we have to state the known and unknown variables, that is the data are the given factors in the question, and we have to use the appropriate formula there. So, first what we have to do? Read the problem, we have to draw the diagram and we have to state the known and unknown variables there, and we have to write the appropriate formulae. And also we have to substitute the known values in the solved equation or formula, and we have to calculate the unknown from the known values. Then we have to check final answer for reasonability, and we have to substitute the final answer into the alternate formula to verify or to confirm our answer or to verify the result. And at the end we have to write the concluding statement which is based on the question asked. My dear student, we have to strictly follow all these things to get the appropriate answer or the correct answer. My dear students, you have learnt about mirror formula in the previous sessions. Just recall the formula which is help us to solve the problem. In mirror formula, we have 1 over f is equal to 1 over v plus 1 over u, where f is focal length, v is image distance and u is object distance. And also we have the formula to calculate magnification. It is the ratio of height of the image to the height of the object, which is also calculated by using the relationship between the image distance as well as the object distance. A negative sign in the value of the magnification indicate image is real, and positive sign in the value of the magnification indicates it is a virtual image. And there is a sign convention for reflection by spherical mirrors and lenses, and we have to remember the coordinate plane to take the positive as well as negative value for the data which is given in the question. So, we have to follow all these things before going to write the data. The first important thing is the object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the left hand side. The second important thing you have to notice, all distances parallel to the principal axis are measured from the pole of the mirror and as well as lens. The third important point is, all the distance measured to the right of the origin, that is along positive side of the x axis, are taken as positive, while those measured to the left of the origin, that is along negative of the x axis, are taken as negative. And also the distance measured perpendicular to the above the principal axis is towards positive side of the y axis, that is why they have to be taken as positive, and the distance measured perpendicular to the below the principal axis, that is towards the negative side of the y axis, are taken as negative. We can conclude our all these points like this. So, here we are going to place a mirror or a lens. In case of lens, optic center will be here. In case of mirror, pole of the mirror will be situated here, and we are going to place the object on x axis, that is negative side of the x axis. The distances are going to be taken negative, height of the object is going to be considered positive, and height of the image, if it is towards negative part of the y axis, here it is towards here, then the value will be minus or negative, and if the image is going to be formed on the positive side of the x axis, then the image distance will be positive, and if the image towards negative part of the y axis, the height of the image is going to be considered as negative. So, this coordinate plane help us to take the sign for the values which is given in the data. Sign convention for reflection by concave mirror. So, in case of concave mirror, so we are going to place the mirror at origin, and the upper arrow mark showing you the height of the object, and where you are seeing here, it is the position of the object on negative part of the x axis, and this downward arrow mark indicating you the image height, and it is towards negative part of the y axis, and here the image is formed on the negative part of the x axis. So, we can simply conclude like this: if the type of the mirror is concave, object distance u is negative, image distance v is negative, object height is positive, image height is negative, and focal length is negative, since the focal length is going to be calculated with respect to the principal focus. The principal focus is located towards the negative part of the x axis, that is why focal length of concave lens is negative. So, these things are very important to solve the problems. If you are going to understand this very carefully, and if you are going to know this all, you can get the correct answer whatever the question which is going to be asked. Now, let us solve a problems based on concave mirror. The question is like this: an object is placed at 25 centimeter in front of the concave mirror. A sharp image is formed on the screen which is placed at a distance of 5 centimeter from the concave mirror. Here we have to find the focal length. So, we need a diagram to write the data, and object is placed on negative part of the x axis, image is also formed on the negative part of the x axis. So, now the values will be like this: object distance u is minus 25, image distance v is equal to minus 5. So, to calculate the focal length, we have to use the formula 1 over f is equal to 1 over v plus 1 over u. If we substitute the values for v and u like this, we will get this step. So, that is 1 over f is equal to 1 by minus 5 plus 1 by minus 25. Let us simplify further. So, here we are getting the minus sign is shifted to the numerator. In both the cases, you will get the negative sign like this. Now, after the simplification by taking the LCM for the denominator, we will get 25 and if you simplify the numerator, we will get minus 5 and minus 1, and at the end we will get 1 over f is equal to minus 6 by 25. Now, what you have to do? You have to take the reciprocal to calculate the focal length. So, therefore, f is equal to minus 25 by 6. Just divide 25 by 6 and you will get answer minus 4.16. So, since it is a concave mirror, the focal length will be negative. Now, let us solve one more problem. So, based on concave mirror, an object is placed at 25 centimeter in front of the concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain sharp image? So, here we have to write the data again by considering the rough diagram, a small rough diagram. So, let us write the data which is given in the question. Object distance u is given, that is minus 25 centimeter, and focal length is given, that is minus 15 centimeter, and whatever the things are given. Image distance v is we have to calculate, then use the formula 1 over f is equal to 1 over v plus 1 over u, substitute the values for the f and u, and you will get the value of v. Just transpose the numerical values from one side to the another side, and you will get like this: 1 over v is equal to 1 over minus 15 plus 1 over 25. LCM for 25 and 15 is 75, and if you simplify the numerator, we will get minus 5 plus 3, then 1 over v is equal to minus 2 by 75. If you are going to take the reciprocal, you will get 75 by 2, and if you simplify 75 by 2, you will get v is equal to minus 37.5 centimeter. So, what we have to do? The screen should be placed at 37.5 centimeter to obtain the sharp image. So, let us learn the sign convention for the reflection by convex mirror. Now, we have learnt about concave mirror. Now, let us learn about convex mirror. So, just remember how the image is going to be formed in case of convex mirror. Here, see the location of the object and formation of the image, as well as the focal length and position of the object and height of the image and all. If we observe this picture, we will get all this data. So, just observe the picture carefully. The object distance u is negative, image distance v is positive, object height is positive, image height is positive, and focal length is positive, and these are very helpful to solve the problem. Let us solve the problems based on convex mirror. So, I have taken worked example 10.2. The question is like this: a convex mirror used for rear view on an automobile has a radius of curvature 3.00 meter. If a bus is located at 5.00 meters from this mirror, find the position, nature and size of the image. So, we have to write the data first. Radius of curvature is given. We have to convert that one to focal length, that is f is equal to r by 2, that is 3 by 2 meters. Object distance u is minus 5.0 meter. So, here positive and negative value depends upon, I told you already, the position of the object as well as the position of the image. Now, image distance v we have to calculate. Now, height of the image h dash is also be calculated. Use the mirror formula to get the answer. 1 over f is equal to 1 over v plus 1 over u. Substitute the value of f and u, and you will get v value. F is given, that is 3 by 2, and u is given, that is minus 5. Take the reciprocal for the left side denominator, you will get 2 by 3 in the left hand side, and in the right hand side 1 over v minus 1 over 5. Now, so if you transpose 1 over 5 to the left hand side, you will get 2 by 3 plus 1 by 5. Take the LCM for the denominator, LCM will be 15, and simplify the numerator, it becomes 10 plus 3, then 1 over v is equal to 13 by 15. Take the reciprocal for left hand side, you will get v, then the value becomes 15 by 13. Simplify the value and you will get v is equal to 1.15 meter. So, that is the image will be formed at 1.15 meter. So, that is the image is 1.15 meter at back of the mirror. Now, what we have to calculate? So, we have to calculate the magnification by using the formula minus v by u, substitute the value minus 1.15 and divided by minus 5, then you will get plus 0.23. So, this is the magnification factor. So, that means the image is virtual, erect and smaller in size by a factor of 0.23. This is what we have to be calculate, and this is what the result for the question which is given. Now, let us move on to the lens formula for the spherical lenses and recall the formula. 1 over f is equal to 1 over v minus 1 over u, where f is focal length, v is image distance, u is object distance, and magnification is going to be calculated with the help of height of the image to the height of the object, and which is mathematically written as m is equal to h I by h o, which is equal to v by u. So, here one thing you have to remember, in case of mirror formula, here you having a plus sign, in case of lens formula, here you have a minus sign. So, in case of mirrors, here it is minus v by u, in case of lens it is plus v by u. So, these are the small differences you have to find and you have to know about mirror formula as well as lens formula. So, let us know the sign convention for convex lens. So, again you have to remember the Cartesian plane as well as the position of the convex lens as well as the position of the object and the image also. So, if you are going to remember all these things, and it is very easy to take the positive as well as negative sign for the data which is given in the question. With the help of the diagram what you have seen now, we can list all these things. Object distance u is negative, image distance v is positive, object height is positive, image height is negative, and focal length of the convex lens is positive. So, you have to be note down all these things. So, with respect to the picture I am showing you, I have written all this sign convention for the convex lens. Let us solve a problem based on convex lens. The object is placed at a distance of 25 centimeter away from the convex lens and the image formed at 5 centimeter away from it. Find the focal length of the convex lens. Here the data which is given is object distance is given and image distance is given. With the help of these two data, we have to calculate the focal length of the convex lens. For that, so in this diagram help us to take the values with respect to the negative sign and positive sign. Write down the data. Object distance u is equal to minus 25 centimeter, image distance v is equal to 5 centimeter, the focal length f is to be calculated. Use the lens formula 1 over f is equal to 1 over v minus 1 over u, substitute the value for v and u, and value of v is 5 and value of u is minus 25. So, here there are two minus sign, one over here and one over here. So, they becomes plus in the next step. So, that is 1 over 5 plus 1 over 25. We can take the LCM for the denominator. We will get 25 as the LCM and numerator becomes 5 plus 1 and 1 over f is equal to 6 by 25. Then f is equal to 25 by 6. So, we are getting this after taking the reciprocal, and if you are going to simplify 25 and 6, we will get 4.16. So, it is the focal length of the given lens. Let us solve another problem on convex lens. Example 10.4 I have taken. A 2.0 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. The distance of the object from the lens is 15 centimeter. Find the nature, position and size of the image, also find its magnification. So, let us write down the data. Image distance we have to calculate, focal length f is given 10 centimeter, object distance u is given minus 15 centimeter, then object height h is given 2 centimeter, then formula we have 1 over f is equal to 1 over v minus 1 over u, substitute the value of f and u to get the value of v. So, we will get like this. So, 1 over 10 is equal to 1 over v plus 1 over 15. Now, 1 over v is equal to 1 by 10 minus 1 over 15. 1 over v is equal to 3 minus 2 by 30, then 1 over v is equal to 1 by 30. Then if we take the reciprocal, we will get v is equal to 30 centimeter. So, that gives us image distance, and we have to calculate the magnification using the formula v by u. Then, so there we have to take the both relationship, that is v by u is equal to h dash by h o. Then h dash is equal to v into h by u, 30 into 2, substitute the value divided by 15, and you will get minus 4 centimeter. Then the magnification m is equal to v by u, which is equal to 30 by minus 15, which is equal to minus 2. Then the negative sign in m as well as h dash shows that the image is inverted and it is formed below the principal axis. Thus, a real and inverted image is going to be obtained in this case. Now, let us learn about the sign convention for the concave lens. Now, the concave lens will be like this, it is going to be placed in the Cartesian plane like this, and here you are seeing the position as well as height of the image, and it is position as well as height of the object. So, based on this, so we can list like this: object distance is negative, image distance is negative, object height is positive and image height is positive. Then remember my dear student, here focal length is negative, since image is going to be formed towards the left side of the or that is negative part of the x axis. Now, let us solve a problem based on concave lens. Here I have taken example 10.3. The question is like this: a concave lens has focal length 15 centimeter. At what distance should the object from the lens to be placed so that it forms an image at 10 centimeter from the lens? Also find the magnification produced by the lens. So, here we have to calculate two things. So, that is object distance as well as the magnification produced by the lens. Now, image distance v is given, that is minus 10 centimeter, focal length is given minus 15 centimeter, object distance we have to calculate, then we have to use the formula 1 over f is equal to 1 over v minus 1 over u, then substitute the value 1 over f, in place of 1 over f we have to write 1 over 15, which is equal to 1 by minus 10 minus 1 over u. So, 1 over u is equal to 1 by minus 10 plus 1 over 15, then 1 over u is equal to minus 1 by 10 plus 1 over 15, LCM for 10 and 15 is 30, then numerator becomes minus 3 plus 2. After simplification, we will get 1 over u is equal to minus 3 plus 2 by 30, which is equal to minus 1 by 30. So, after the simplification of all this value, we will get u is equal to minus 30 centimeter. So, that is the object distance. Now, we have to calculate the magnification by using the formula minus v by u, that is minus 10 by minus 30, which is equal to 1 by 3. The positive sign shows that image is erect, virtual and image is 1/3 of the size of the object. So, we have to note this. So, this is how. So, we should solve the problems based on lens as well as mirrors. Let us come to the last concept of today's session, that is power of a lens. The power of a lens is the reciprocal of the focal length of the lens, or the reciprocal of focal length of a lens is called the power of a lens. It is represented by the letter P. The power P of the lens with focal length f, which is given by P is equal to 1 over f. So, power is the reciprocal of the focal length. So, the SI unit of power of a lens is diopter, and it is going to be denoted by the letter D. 1 diopter is the power of a lens whose focal length is 1 meter, that is 1 D is equal to 1 per meter. The power of convex lens is positive and power of a concave lens is negative. So, these are the important points regarding the lesson. My dear student, I hope you have enjoyed this session very well, and now you are capable to solve the problems based on lens and mirror. So, based on today's concept, you have a home assignment. My dear student, solve the exercise problems which is there in page number 96 and verify your answer. My dear student, thank you for watching this program. I hope you understood today's concept as well as the concepts of this lesson very well. Keep studying well, have a great time, stay safe and keep learning. Thank you so much.